Hello, my name is Isaiah Stapleton. I work on the Red Hat research team and in the Mass Open Cloud, and today I'm going to be going over how to deploy an AI model on Red Hat OpenShift AI. The purpose of this guide is to essentially just offer the simplest steps for deploying an AI model on Red Hat OpenShift AI. This guide today will specifically be covering deploying the Granite model using the VLM serving runtime for Kserve. This guide assumes that you already have a cluster that is configured, an OpenShift cluster that is configured for model serving. I have another guide that I went over doing exactly that, configuring an OpenShift cluster for model serving. So if you don't already have that set up, just take a look at that guide and you'll be able to follow along with this guide. In addition to deploying the model, this guide is also going to cover setting up a simple observability stack so that you're able to collect and visualize metrics related to AI model performance, such as throughput, latency, time to first token, inter-token latency, etc., and GPU information such as the temperature of the GPUs and the GPU utilization. This guide is broken down into 5 parts. The first part is going to be deploying S3 storage using MinIO. We need this because that is what we use to actually store the model. So then after that, we will download the model from Hugging Face and then upload that model into that S3 MinIO storage. At this point, we'll be able to actually deploy the model on Red Hat OpenShift AI, and then we can set up a simple observability stack to collect metrics related to our GPUs and our deployed models. So let's first go over deploying S3 storage using MinIO. Just like in the last guide, I have a repository that contains all the steps that we'll be going over today, so I will essentially just be going through each step and talking through it. First, we need to deploy MinIO in the project namespace. I've created a namespace demo for the purpose of this guide, but you can use whatever namespace you want, such as the sandbox namespace that was used in the guide for configuring the cluster. You need to make sure that you are logged into your cluster through the CLI, which you can grab that token here, like I mentioned last time. I am already logged into the cluster and I can check by doing OC project, and I can see I am connected to my cluster and I'm also in my project namespace. So let's deploy this MinIO S3 storage. We can take a look at the manifest that is used for deploying MinIO under MinIO setup here. And you can change some value. So you can change how big the storage is. I have it set to 50 gigabytes for this guide, but you can change it to much smaller. I think you need at least 10 gigabytes of storage, so just you can leave it as default or you can change it as needed. Another thing you can change here is the login, the username and password for accessing the MinIO UI. So you can change that here. I'm just going to leave it as the default for the purpose of this demo. So I'm going to do the MinIO setup. I'm going to do this OC apply. And just like in the last demo, I need to have proper credentials for doing so. So I run it as system admin. So you can see all of the resources have been created. I can take a look in the UI and I can see this MinIO container is being created. Need to wait a minute for the pod to start running. It is now running, and now that it's running, we can check routes. And you can see here that there is 2 routes. The one is for accessing the MinIO API, and the other one is for actually accessing the MinIO UI. So you can use that login that we used before, or the login that we specified in the manifest for the MinIO setup. I just used the default, so it's MinIO, MinIO123. And now we can access MinIO through the UI this way. Now that we have our S3 storage properly set up, we can go ahead and download the Granite model from Hugging Face. So in order to download the model, we need to navigate to Hugging Face. Before we can actually just download the model, we have to create an access token. So we can do that by going to Settings, going to Access Tokens, and then hitting Create New Token. And we just need read access. So for token type, you can just select read because we're just going to be reading from the Granite repository and cloning it. So I will just call this demo, and then I will copy the token down. And then we should be good to go for downloading the model. This is the way in which we will be downloading the model with this command here. It's a git clone, and then you can pass in your Hugging Face username. For me, it's Isaiah S1, so my command would look something like this: Isaiah S1, pass in my token, and then, like I said, specifically we're going to be doing the Granite model, so I would pass in this path for the URL for the Granite model. Let's actually take a look at that repo for the Granite model here. So this is the repo for the Granite model. And you can see these safe tensors here. These safe tensors file format is a way for actually storing a AI model. So this Granite model is essentially these safe tensor files. So now that I have my access token, I will go ahead and download the model. I will just copy this command since it already has my Hugging Face name in it and it already has the path for the Granite model. I will just need to pass in the token here. So I will copy that token that I have just created, that here, then I will run this command. It might take a second because the model itself is pretty big. Each safe tensor is, except for the last one, is 5 gigabytes. So it's around 15, 16, 17 gigabytes. So it may take a minute. So the model just finished downloading. It took about 3-4 minutes to finish downloading. So I can see it here in this Granite 3.0, 8 billion instruct repo. It contains all of the safe tensors. So we now have our S3 storage set up. We now have downloaded the Granite model. So now we just need to upload the Granite model into our S3 storage. So in order to do this, we're going to need to navigate to the MinIO UI. Like I mentioned previously, in order to get to the MinIO UI, you can just go to the networking routes, and then you'll see within your namespace, and you'll see the MinIO UI, and you can just hit that and log in with your credentials. So I'm already logged in, so I'm going to first have to create a bucket. This bucket is basically where your models are going to be stored, so I am just going to call this bucket models. I'm going to create this bucket, and then I can go to the object browser and I can see the bucket here, models. And then within this bucket, we are able to upload our model. So hit this upload and then hit upload folder. And I am going to go to the model that we just downloaded, the Granite 308 billion instruct, and I'm just going to upload this model. So you can see here everything from that directory is being uploaded. This step is going to take a long time. Like I mentioned, the model's pretty big, so this step takes a while. It's going to take, I don't have an exact time, but it may take like 45 minutes to an hour. So yeah, once you do this, you can step away for a bit and we'll come back once this is fully uploaded. So the model is finished uploading. It actually did take a little bit longer than an hour. It took about an hour and a half. But you can see now within the models bucket, we have the Granite instruct directory, and it contains everything for the model, including the safe tensors. Now that we've uploaded our model into our S3 storage, we are now ready to deploy that model on Red Hat OpenShift AI. So the first thing that we're going to have to do is create a data connection to our S3 storage. That way Red Hat OpenShift AI knows where to find our model in order to actually deploy it. So we're going to need to navigate to the Red Hat OpenShift AI UI. If you don't remember how to get there from the OpenShift console, you can hit this icon at the top and hit Red Hat OpenShift AI, and that will open the UI. Then we can navigate to data science projects and then go to your project namespace. I've been using demo. And then we will need to go to connections. And from here, we can create a connection. The connection type that we're creating is a S3 compatible object storage connection. You can give it a name. I'm just going to call it MinIO. And then the access key and the secret key are the username and password that you used to access the MinIO UI that you specified in the MinIO setup YAML. So for me, it was MinIO and MinIO123. And this endpoint here, you can find within networking routes, and then it's going to be the MinIO API. And so I'm just going to copy this, paste that here at the endpoint. And then for region, you don't have to fill this out, but I usually just put US East 1. And then bucket is going to be the bucket that you have your model stored in. So for us, it was the models bucket. Then hit create. And now we have a successful connection to our MinIO S3 storage. So now that we have our S3 data connection, we can go ahead and deploy our model. So head on over to the Models tab, and we are going to select the single model serving platform. And then we are going to hit Deploy Model. For the deployment name, I'm just going to call it Granite. And then for the serving runtime, we are going to be using the VLLM serving runtime for Kserve. For the model server size, I'm just going to leave it as small. And then for the accelerator, I'm going to use a NVIDIA GPU, which is a NVIDIA A100 GPU. Then I'm going to select make deployed models available through an external route. That way we can access the endpoint for the model outside of the cluster externally. But I'm also going to keep this checkbox ticked for require token authentication. This makes it so that when you query the endpoint, you have to provide it a token. So it acts as a form of authentication. That way, not just anybody out there can go and query our model endpoint. And then we need to select the source model location. So we're going to select the MinIO storage, the data connection that we just created. And then for the path, you're going to provide it the path to the model within the models bucket we created. So for us, the path is this directory here. So I'm just going to copy and paste the name. And now that we have that, we don't need to change anything else. Everything looks good. So we can go ahead and hit deploy. Now that we hit deploy, we can go over into the OpenShift console. We can go into pods, and we can see that we have this Granite Predictor pod here that is in the process of starting up. This is going to take a bit, so I will wait for it to finish, and then we will continue. So a few minutes have passed, and the Granite Predictor pod is actually now in a terminating state. This is a bug that I have run into often, and the issue is noted here. Essentially, after deploying the model, the first time you deploy it, it may terminate, and this only happens for larger models. So for our Granite model, it's a pretty big model, and it happens nearly every time. You can see the pod's fully gone now. So when this happens, all you need to do is go to deployments, and then you just need to scale it back up. So once you scale it back up, this second time that it spins the pod back up, it doesn't run into that termination issue, and it does start up successfully. So just be mindful of that if you're deploying the Granite model as of today. You are going to run into this issue most likely, and the solution is to just spin up the deployment back to 1, and then you will not run into any issues again. The pod will spin back up, and your model will be successfully deployed. Hopefully by the time you get to this guide, this bug will be fixed, but for now, this is the workaround for it. So I will just wait again for the pod to spin back up, and then we will continue after that. So the pod is now up and running, and if I go into the Red Hat OpenShift AI UI, I can see under status for my model that it is available and loaded. So what I'm going to want to do next is query that endpoint. I usually start with just one of the simple endpoints, that being the V1 models endpoint. What this does is it basically just returns some information about the models that are being served. I do this first just because it's a simple query, and I can just see if the model is able to accept a request and return some information. So I'm going to copy this, and where it says URL, I'm going to replace that with the URL for my model. You can get that from the UI, where it says internal and external endpoint details. Copy this URL, put that here. And then remember that we set up authentication for our endpoint. So where it says your bearer token, you're going to have to provide it that token. You can get this token by hitting this little drop down next to your model, and it will be down here. And I can just copy this token secret. So I will put that here and then submit the request. And you can see that it returns some information about my model here. So now that I know that the model can return some information, accept a request and return some information, I want to test out if inferencing is working. So the next endpoint I'm going to test is the v1 completions endpoint. I'm going to grab this command. What the v1 completions endpoint does is it basically takes a text prompt that you specify here in prompt, and it will return a completed text response. So I'm going to do, just like I did before, replace the URL for your model endpoint, and then replace the bearer token with this token here. And then where it says model name, you need to provide it your model name that you deployed your model with. You can see that it has uppercase G for Granite here, but it actually only uses lowercase letters. So it's going to be just Granite. You can test this by when we queried the models endpoint, you can see here ID. This is the name of the model and it's Granite here. So pass the name of the model, which is Granite, to this model here. And then I'm just going to leave the prompt as the default. San Francisco is A. And then max tokens, I'll leave that as default 7. That just that's how many tokens or words that will be returned. And then temperature, I will leave it as this default. What temperature is, it is basically just a measure of randomness. So the lower the temperature, the more deterministic the response will be. So if it was set to like 0, you would expect it to return the same output every single time because there's no randomness to it. But for me, I'm just going to leave it as the default and see what I return. So I submitted the request, and you can see here the text response was San Francisco is a city with a rich history. So you can play around with this. You can change this. Maybe we can change it to Red Hat is a, and let's get a lot more tokens. Let's get 100 tokens back. So you can see that it completed the response and it returned 100 tokens. So I can see that my deployed model is accepting requests and returning responses and is able to properly do inferencing. So at this point, you have successfully deployed the Granite model on Red Hat OpenShift AI using the VLLM serving runtime for Kserve. So now that we've successfully deployed the Granite model, we can set up a simple observability stack and collect metrics related to the performance of that AI model, as well as metrics related to the GPUs. So the first thing that we're going to have to do is configure Prometheus. So Prometheus comes installed by default with OpenShift. However, the default monitoring stack, it only collects metrics related to core OpenShift platform components. So we're going to need to enable user workload monitoring in order to collect metrics from our model. So in order to enable it, you basically just set enable user workload true in the cluster monitoring config map object. I have this YAML that will do that for you here, but we can take a look at what the YAML looks like. It looks like this. It basically just passes this enable user workload into the config in the OpenShift monitoring namespace. So I will do that. Okay. And then once that is done, we will need to add VLM metrics to the user workload metrics allow list. So let's take a look at this YAML for doing so. And you can basically see there's this user workload metrics list YAML. So you can specify this per project namespace, what metrics you want Prometheus to gather. Since we are using the VLM serving runtime, the VLM serving runtime exposes metrics that start with this VLM colon prefix. So I'm basically, by doing this, I'm just telling Prometheus, like, please grab those metrics for me. but we need to set the project namespace. So let's set that namespace here. Again, we're using the demo namespace. Make sure it looks good, so it has demo, and then I will be able to apply that config map. And now we have told Prometheus, please gather these VLLM metrics for me. So now that we've configured Prometheus to gather these metrics that we are interested in, we need to install and set up Grafana. Grafana will be used in order to visualize these metrics. So I'm going to deploy Grafana in its own dedicated namespace. And then next we are going to actually deploy Grafana. Let's take a look at the YAML that we use for deploying Grafana. We have a PVC that's going to be used to store some metrics, the deployment that actually has the Grafana instance, and then a service that is going to be used in order to access the web UI. So let's go ahead and create the Grafana instance. Let's deploy this. Okay, and we can see that it created those resources. Let's go to the Grafana namespace. We can see the Grafana container is being created. So the next step is going to be exposing the Grafana UI externally. So let's take a look at that YAML and see what that entails. So it's basically just creating a route that points to the service, this service here on port 3000. So it basically just exposes this port externally so that you can access it from outside the cluster. So once the pod is running, which it is, we can go ahead and apply the route to expose the Grafana UI externally. Now that we created that route, let's grab the Grafana URL. And you see it says application not available, but it may just take a few minutes for things to get up and running. So I will wait a minute or two. So it took about a minute and then I refreshed the page and I was able to see this web UI for Grafana here. So I will log in and the default login is admin and admin. So admin username, admin for password. It will prompt you to change the password. For the purpose of this guide, I don't care to do so, so I will just skip. And now you are able to see the Grafana dashboard. So now that we can access the Grafana web UI, we need to add a data source so that we can access the Prometheus metrics. So we need to first create a Grafana secret token, which we can do by running this command. It actually has an error. It's not supposed to include this namespace Grafana here. I will remove that right after this guide, so by the time you see it, that won't be there. So I will just run this command in order to create that token. But I'd already run these, I just ran these commands, so this isn't creating anything new, but I can go ahead and grab that token by doing the following. And so I have my token here. So now let me add the Prometheus data source, go to your Prometheus UI, go to data sources, and then hit add data source, hit Prometheus, and then you have this Prometheus server URL. That server URL is going to be this here. So I will copy this link, put that there. And then I will hit skip TLS certificate validation. And for the HTTP headers, we will need an authorization header. And then value will be bearer, and then that token that we just grabbed here. Copy this token. And I will just paste that here. So then once that's done, you can scroll down and hit save and test. And you should see successfully queried the Prometheus API. So now I can just go into the Explorer view and I can see, let's see. So we can see these DCGM metrics. So these are exposed by the NVIDIA GPU operator, so it gives us insight into metrics related to the GPUs. This here was probably when I was, well, this metric here is GPU utilization, so this jump here was probably earlier when I was sending inferencing requests to the model. And let's see if we are able to see the VLM metrics, which we are. So we are able to now see within Grafana metrics related to the GPUs, and we are also able to see metrics related to the models that are deployed themselves. You can see here, model name, Granite. It's the only model I have deployed, so it's the only one showing. But you can look at all these metrics. You can hit Metrics Explorer too. So you can see all the DCGM metrics, all the VLM metrics. And yeah, so now we have added a data source to Grafana that we can use to visualize the metrics that are gathered by Prometheus. So now that we have the Prometheus data source that lets us look at all these metrics that Prometheus is gathering, let us now import the VLM dashboard. So we have this dashboard as a part of the emerging tech and Red Hat research repositories. This is the one that we use. So I'm just going to hit copy here, and then I can go to dashboards, create dashboard, import dashboard, and enter this. Then I will import this, and you'll see that there's an issue here with this data source not found. You can just solve this by hitting edit and then hitting run query again, and then just exiting out of the panel. I'm not sure what exactly causes this. Hopefully this is fixed by the time you see this, but for now you can just go in and hit edit, and then it should fix the data source issue. But yep, that's all you need to do in order to import the VLM dashboard. This gives you information about your models, the performance of them, gives you the request latency, token throughput, time per output token latency, etc. You can glean all this information from this dashboard by just easily importing it into your cluster. The last thing that we're going to do is import the NVIDIA DCGM dashboard. This dashboard will give us insights into our GPUs. So we can do that easily by going to dashboards. You can hit new, hit import, and where you see Grafana dashboard URL or ID here, you can just copy this URL here and then hit load. Select your data source, which will be Prometheus, and then hit import. And now you have the NVIDIA DCGM exporter dashboard in your cluster. So now you have both the NVIDIA DCGM exporter dashboard and the VLM dashboard. That now concludes the guide for deploying models on Red Hat OpenShift AI. You were able to deploy the Granite model using the VLM serving runtime on OpenShift AI, and then set up some simple observability stack using Prometheus and Grafana in order to gather metrics related to the AI model performance, as well as metrics related to the GPUs themselves. Like always, if you have any questions, please reach out to me at my Red Hat email, istaplet@redhat.com.